Hi, we're going to talk about probability today and then try to tie it in to the Punnett square. As the sentence here tells us, a probability tells you how likely an event is to occur. This might work in flipping a coin, rolling dice, rolling a die, predicting the weather, many different things related to probability. So it's not guaranteed to be an exact match. If the prediction of flipping a coin says that 50% of the time it should be heads, you flip it 10 times and you get tails 8 times. That's because it's only a probability. It's not guaranteed. Okay. The more times you repeat it, the fraction should get really close. So if you flip a coin not just 10 times, but if you flip it 1,000 times, it's more likely to be closer to 500 heads and 500 tails. Right. So again, the more repetitions, the more accurate the estimate. All right. This just represents the likelihood of an event occurring for a single trial on an experiment. So again, if it says a 50% chance, it's 50% chance each time you flip that coin that it's going to land on heads. It's also a 50% chance it's going to land on tails. That's what it's talking about, that one trial. Okay. Regardless of the tries, a coin that flipped should be equally likely to land on heads up as tails up. So it doesn't change it. More times you do it, it does not change the probability. It's always 50%. Okay. So if we look at sports and we say someone's up there to shoot a free throw and they make a free throw 75% of the time. So out of 4 shots, this basketball player should make 3 shots. But there's no guarantee that if this basketball player shoots 4 shots during a game, every game, then it's no guarantee that that basketball player will make 3 shots every time they shoot 4. It is only a probability of past experience. Okay. Speaking of illness, and there's always predictions here. During flu season, let's say the chance of getting the flu is 1 out of 8. So if there's a family of 8 living in the same house, is it guaranteed that one of them will get the flu? Sounds like it should be 1 out of 8. Well, again, this is not a guarantee. This is a guess. It's possible that none of the people in the house could get the flu, or it's also possible that more than one, because 8 is a very small number. It would make a difference if we were talking about 8,000 people in an area that 1,000 would get it. This is a very high percentage, and I'm glad it's not this high. So looking at Punnett square related to probability, first we'll just talk about how do we fill out a Punnett square. First, we have the female on the left here that is heterozygous dominant, and this is talking about a tall versus a short pea plant like Gregor Mendel the monk did so long ago. And then the male is on the top here, heterozygous tall with a capital T and a lowercase t. The female is capital T, lowercase t, so they both are heterozygous tall plants. So the first thing that happens is the female large T comes here. Then the male T comes down to here. So this offspring is going to be homozygous dominant. Then this female large T goes here, from here. And then the lowercase t comes down from the male. This is going to be heterozygous dominant. All right. Now, on the lower level, just out of tradition, we usually put the large capital T in front. This capital T comes from the male. Lowercase t comes from the female. So this is heterozygous dominant as well. And finally, last but not least, in the bottom right-hand corner, we have a lowercase t coming from the female, lowercase t coming from the male. So this one would be homozygous recessive. All right? Talking about this, probability related to genotype. Genotype is what the gene makeup looks like. We use alleles to represent these because looking at these under the microscope would not be easily represented. We represent them with letters so we can understand. What's the probability of an offspring getting type 2 capital T's? Well, there's 4 offspring boxes. Okay? So 1 out of 4 is 1/4, and that converts to 25%. So there's a 25% chance every time this male and female plant is crossed that one of the offspring is going to be homozygous dominant. So the next time they cross, there's another 25% chance. Okay? The probability of having a genotype, which would be heterozygous or hybrid tall, capital T, lowercase t, there's 2 of them out of 4 total. That's how we get the fraction 2 out of 4. 2 out of 4 we know reduces down to 1/2. 1/2 of anything is always 50%. Okay, last but not least, we have 2 lowercase t's here. 1 out of 4 gives us 25%. So the probability of getting heterozygous dominant is going to be a 25% chance. To get heterozygous dominant, it's going to be 2 out of 4. That's the rule of addition you might learn about in biology later. And homozygous recessive is 25%. Hope this was helpful in figuring out probability related to a Punnett square.